You know, every time you ask an AI chatbot to write an email, a machine in Chile drinks a glass of groundwater.
Yeah, it is, it's quite the image.
Welcome to the deep dive. We've spent, decades thinking of the internet as this weightless, frictionless cloud, right?
Right, totally weightless.
But today, looking at a stack of intelligence reports and news from May 28, 2026, we're going to explore a quiet but massive structural shift hiding right in the headlines.
Yeah, it's all right there if you know where to look.
Exactly. Our mission today is to track where that ethereal cloud is violently crashing into the ground. But I want to start by throwing an observation out there. Just something for you to sit with for a moment before we really get into it.
Okay.
AI used to feel like software. Now it may be becoming an industry of water and electricity.
Oof. Yeah, it is a profoundly uncomfortable thought, honestly.
It is, right?
Because we've spent the last, 30 years being conditioned to think of the digital world as entirely separate from the physical one.
Yeah, totally disconnected.
Right. I mean, the terminology we use, wireless, cyberspace, the cloud, it all implies this floating existence completely detached from the heavy, dirty, physical realities of the Earth.
Yeah.
But when you start connecting the data points we are looking at today, you start to get this strange, almost creeping feeling.
Yeah, that artificial intelligence, local cities, semiconductor manufacturing, power grids, and, municipal water supplies, they are somehow all becoming the exact same story.
Exactly the same story.
Okay, let's unpack this.
Yeah.
Because for years, you and I and everyone listening thought we were building a magical digital realm.
Right.
But today's sources are painting a very different picture. They show that this cloud is hitting the immovable physical limits of everyday infrastructure.
Yeah, and to understand the physical footprint of AI, we actually have to take a step back and look at how we chronically misunderstand speed in the physical world.
Oh, that's interesting. What do you mean by speed?
Well, we are obsessed with the speed of data, the speed of financial transactions. But the physical world operates on an entirely different, incredibly stubborn timeline.
Right. Physics doesn't care about fiber optics.
Exactly. And there's a geopolitical event happening right now that serves as like the ultimate example of this friction between fast markets and slow physical reality.
Okay, you're talking about the situation in the Strait of Hormuz.
Yes.
Because we are looking at reports suggesting an informal draft memorandum of understanding MOU between the U.S. and Iran.
Right.
And the stated goal of this draft is to restore commercial shipping in the Strait to pre-war levels within a month.
And predictably, the financial markets react to this news in milliseconds.
Oh, instantly. Oil futures shift. Trading algorithms scan the text of the MOU, they see the word agreement, and instantly execute millions of trades.
Right. The financial layer sees a signed piece of paper and assumes the physical world has already changed.
Yeah.
But what's fascinating here is shipping can restart faster than trust.
Shipping can restart faster than trust.
Yeah. You can have a political agreement signed in an afternoon, but a massive cargo ship doesn't move on politics alone.
No.
It moves on a deeply complex, incredibly slow physical operating system. We call these slow recovery layers.
Wait, I want to challenge that reaction from the market, actually. Are we mistaking a drop in oil futures for actual physical recovery?
Yes, very often we are.
Because, if the governments involved agree to let the ships pass and the political barrier is gone, what is actually holding those vessels back? It feels like they should just go.
It's the mechanics of risk and physics, really.
Yeah.
Let's look at the reality on the water. First, you have maritime insurance.
Oh, right. Insurance.
Insurance actuaries do not care about a draft MO. They care about mathematical risk models.
Yeah, they want hard data.
Exactly. They have to recalculate the exact probability of a stray mine hitting a hull based on new physical sweep data.
And that takes time.
It takes weeks of intense mathematical modeling before a new premium is set. And until that math is done, and the insurance syndicates actually sign off, those ships legally cannot leave port.
Wow. So the algorithm trading oil futures thinks the problem is solved, but the insurance underwriter knows the ocean is still the ocean.
Exactly. And even beyond insurance, you have physical mine clearance.
Oh, yeah.
You can't just declare a highly contested waterway safe by treaty. You have to physically sweep it, meter by meter, with specialized sonar and diving teams.
Right. Someone literally has to get in the water.
Yes. Then you have port operations that have been disrupted, labor forces that have been scattered, and the highly specialized logistics of liquefied natural gas or, LNG transport.
That's a lot of physical pieces.
These are the physical operating systems of the world. So the financial layer moves at the speed of light, but the physical layer requires massive amounts of time and energy to resynchronize.
I see. So it's a profound mismatch in velocities. The financial market says, go, but the physical reality says, wait, someone actually has to put on a diving suit and check the hull first.
Precisely. And if we connect this to the bigger picture, this severe friction between hyper-fast digital mandates and slow, heavy physical realities, that is the exact same dynamic driving the evolution of artificial intelligence right now.
Well, that makes so much sense.
The venture capital funding AI is flowing instantly. The algorithms are iterating at light speed.
Right.
But all that abstract math has to land somewhere in the physical world. It needs concrete, it needs copper.
Which brings us directly to how we build the physical supply chain for an industry moving that fast.
Yes, it does.
Because we have a major report here about Samsung building a $1.5 billion semiconductor testing factory in Thanh Nguyen, Vietnam.
Right.
And our sources explicitly state this isn't for old school tech. This is being driven entirely by the massive memory shortage caused by AI data center demands.
Yeah, and if you're just skimming a standard financial newspaper, this is usually framed as a simple story of foreign direct investment.
Sure, Vietnam's economic growth.
Right, but that is a profound misreading of the structural shift that is actually occurring on the ground here.
Okay, here's where it gets really interesting. Because you're saying we shouldn't view this as a traditional nation-state economic victory. The geometry of the global economy is shifting.
It is. We need to reframe this entirely. AI may be selecting cities.
I'm going to push back on that, or at least ask for some clarity.
Sure.
Why Vietnam? I mean, if AI just needs massive amounts of power and space to build chips, why go to a densely populated areas in Southeast Asia at all?
It's a good question.
Why not just build these massive testing facilities next to existing power plants in the Texas desert or, I don't know, somewhere with unlimited open land? How does an algorithm select a specific city?
To answer that, we have to look at the mechanics of what is actually being built. For the listeners who follow the global chip wars, you know that large language models are currently bottlenecked by memory bandwidth.
Right, getting the data in and out.
Exactly. It's what engineers call the von Neumann bottleneck. You have to get massive amounts of data in and out of the processor fast enough to train the AI. So testing and packaging DRAM and NAND memory isn't just standard manufacturing.
It's more complex than that.
It is an implementation layer. It is the highly sensitive physical bridge connecting the hyper-fast world of AI to the slow, heavy physical world.
Okay, so it's the physical choke point.
Yes. And to build that bridge, AI capital isn't looking at a map of nation-states. It isn't looking at borders or national identities. It is hunting for very specific urban nodes that possess the exact right plumbing.
The plumbing.
Yeah, you can't just put this in a desert because a billion-dollar testing facility requires massive, uninterrupted, highly stabilized electricity grids.
Where the voltage doesn't fluctuate even a fraction of a percent, I imagine?
Exactly. And it requires deep water ports to move raw silicon and chemicals in and out. It requires a massive pre-existing labor pool of technicians who already know how to operate inside clean rooms.
Ah, so it requires an incredibly specific urban operating system.
Exactly. If an urban node has those physical attributes, the port, the grid, the labor, the AI capital flows into it.
If it doesn't?
If a city does not have those things, the capital bypasses it entirely, regardless of what country it happens to be in.
Wow. It's like AI is water finding the path of least resistance. It doesn't care about the political borders drawn on a map. It only cares if a specific city has the urban capacity to plug it in without blowing a municipal fuse.
That's a great way to put it.
So Thanh Nguyen isn't just experiencing random economic growth, it's being actively selected as a critical node because its local operating system can handle the sheer physical weight of the AI supply chain.
And this raises an important question about how we view global power dynamics,
Yeah, how so?
Well, historically, we have measured strength in terms of national GDP, national armies, and national policies.
Yeah.
But what we are observing here is that urban nodes-specific cities with high-capacity infrastructure are becoming more important than the nation-states that surround them.
That is wild.
The nation is increasingly just the background environment. The city is the actual interface where the digital world touches the physical world.
I have to admit, I find that deeply unsettling. The idea that a multinational AI supply chain has more direct leverage over a city's infrastructure than the host country's government does.
It is unsettling. Yeah.
It feels like a total inversion of how geopolitics is supposed to work. But it also leads to an obvious looming problem. If AI is hunting for cities with enough capacity to handle this massive physical footprint, what happens when the city runs out of capacity?
Right.
Because water isn't infinite. Power grids certainly aren't infinite.
And that is the exact tension point where the entire system starts to warp. This brings us to what is arguably the ecological and emotional core of our analysis today.
Yeah, let's get into that.
We have reports that big tech, so Microsoft, Google, Amazon, Meta, has launched a massive climate tech initiative specifically targeted at their data centers.
Right, and on the surface, that sounds like standard corporate PR, right? Green initiatives, pledging to be carbon neutral by 2040, planting trees, all that.
It does sound like that.
But knowing what we've just discussed about the intense physical plumbing required for AI, I'm guessing this isn't just about good optics.
No, it is about hitting a hard existential physical limit. The reason they are suddenly deeply invested in this initiative is because of places like Quilicura. It's a community near Santiago, Chile. Our reports highlight a massive concentration of data centers that have been clustered in this specific urban node.
Okay, another urban node.
Right, and this concentration of AI infrastructure is physically colliding with a historic mega-drought in the region.
A mega drought. So the digital expansion is quite literally running out of physical water. How does that actually happen? Walk us through the mechanics of why a data center needs so much water.
It comes down to the stubborn laws of thermodynamics. You cannot destroy heat, you can only move it.
Right.
And the servers that train and run complex AI models run incredibly hot. An AI query requires significantly more computing power and therefore generates significantly more heat than a standard web search.
Yeah, like magnitudes more.
Exactly. To keep the silicon from physically melting down, you have to move that heat away from the servers. And water is one of the most efficient mediums on Earth for transferring heat.
So they pump water through the facilities.
They pump millions of gallons of water through massive cooling towers, where the water absorbs the heat and evaporates into the atmosphere.
Wow.
In Santiago, this insatiable demand for cooling is heavily drawing down local groundwater levels and actively degrading the surrounding wetlands.
That's devastating.
The reality we have to observe here is that AI is no longer an information industry.
No.
It is increasingly a heavy power industry, a cooling industry, and a water industry.
I really want you to think about that mechanism. When you or I type a prompt into a chatbot, we don't think about the thermodynamics of the server rack.
Never.
We just see the text pop up on our screen. We assume the transaction is entirely digital. But the physical reality is that we are essentially forcing an industrial cooling tower in Chile to draw from a depleted aquifer.
Yeah.
The frictionless cloud is tangibly tethered to the water table in South America.
What we're seeing is market expansion moving faster than ecological recovery.
There's that friction of speeds again.
Exactly. The AI market, fueled by billions of dollars of immediate investment, can design, permit, and construct a massive data center much faster than an aquifer can replenish itself from natural rainfall.
Wow.
You cannot venture capitalize a rain cloud. It is a fundamental mismatch in speeds, exactly like the friction we saw with the physical ships in the Strait of Hormuz.
The actuaries and the algorithms.
Yes. The financial mandate to compute is moving at light speed, but the hydrological cycle of the Earth is moving at its own ancient, unchangeable pace.
It's an incredible evolutionary bottleneck.
Yeah.
It's like we suddenly bred a technological superorganism that thinks 1,000 times faster than us.
Yeah.
But we completely forgot that a faster brain requires a significantly larger cardiovascular system to pump cooling blood.
That is a perfect analogy.
And right now, AI's brain is rapidly outgrowing its planet-sized cardiovascular system. So what does this all mean? We have this logical, hyper-advanced software system, and it has a complete structural incompatibility with the physical, urban, and ecological systems it relies on.
It means we are reaching a point of profound, sustained friction. And the most vital thing we can do right now is to stop looking at these global events as isolated incidents.
Yeah, we have to connect them.
The slow, trust, and delayed physical recovery in the Strait of Hormuz, the hyper-specific city selection happening for semiconductor testing in Nguyen, and the severe water constraints colliding with data centers in Santiago. These are not three separate news stories.
They seem entirely unconnected if you just read the headlines, though.
Yeah.
geopolitics in the Middle East, manufacturing economics in Southeast Asia, and hydrology in South America.
But underneath the headlines, they are all symptoms of the exact same structural pressure. They are all manifestations of the high-speed digital and financial worlds colliding violently with the stubborn, immovable limits of physical infrastructure.
Yeah.
Of the world's abstract operating systems, the financial markets, the AI algorithms, the risk models, have achieved a velocity that the physical world, the deep water ports, the power grids, the water tables, the insurance actuaries simply cannot match.
And when a high-speed system grinds against a low-speed system, the result is always friction.
Always.
You get heat. You
Yeah.
get fractured supply chains, drained wetlands, and physical ships waiting weeks for an underwriter's math to catch up to a politician's treaty. It's almost as if the digital realm has entirely outgrown the physical container we built for it.
Which leaves us with a rather profound geopolitical puzzle to consider.
Okay, what's that?
Well, if AI capital and digital infrastructure are increasingly bypassing national governments and instead negotiating directly with the physical limits of individual urban nodes, checking to see if a city has enough water, enough stabilized power, enough port capacity.
Then the nation-state isn't the primary layer of interaction anymore.
No.
The host country is just the geography where the urban operating system happens to reside.
Exactly. It forces us to ask a question that challenges the core of how we understand global architecture.
Okay?
What if the world is being reorganized through cities rather than nations?
Whoa.
What if the future map of global influence isn't drawn by national borders, but by the location of stable electrical grids, specialized labor pools, and robust groundwater reservoirs capable of sustaining the massive physical weight of the artificial intelligence era?
We're going to leave you with that thought to mull over. We aren't going to offer a neat resolution here, because there isn't one.
No, there really isn't.
There is no quick fix to make the heavy physical world move as fast as the digital one, and there is no algorithm that can generate millions of gallons of cooling water out of thin air. The friction between the cloud and the ground is not something that is going to be solved tomorrow. It is simply a new structural reality that we all have to live with. The world may look slightly different now.